Okay, good morning. This is our first of our TAKS topics that we're going to go over. There's 10 of them, one for each TAKS objective. These will also be applicable to STAR students, maybe not quite as difficult as a lot of the STAR questions, but it's certainly a good review. And we'll do more STAR material as we go on. This is a student will describe functional relationships in a variety of ways. These are some examples taken from some released TAKS tests. So I'm going to go over some of the things you might see. Now, if you want to crank this out by hand, certainly that's doable. It's not that hard. What you want to do is you want to start, and this is your X value here, and this is your Y value here. And you can figure out first the slope. Anytime you notice these are y equals mx plus b, only this is the b and this is the m because it's by the variable p. And so we have to figure out our slope. Remember, m is the slope. And so we have to figure out what the slope is. And my pen's not writing too great, but oh well. So to do that, we find the difference here, and 3910 minus 3685, well, it must be 225 because all of those are 225, but we can verify that just to be safe. Okay, so that's 225, and we notice it's minus, so it's minus 225. And this will be at minus 225 for each of these as we go down here. And these are plus 1, this difference here, and that's a triangle meaning delta, is plus 1 for each of these. So the slope is always, if you remember, the difference in your y over the difference in your x values, which will be negative 225 over 1. Okay, so we can see right away, we can eliminate A and C because those are the positive, have a positive slope, and we would need a negative slope. Now we want to know the y-intercept, which is going to be where x equals 0. So the y, B is going to be, remember, B is where x equals 0. Well, that would be the point up here at where x is 0. And if this goes up by 225 each time, as we go up here, well, when we get to 0, what we're going to have, we're going to have 3910 plus 225, which is going to be 4135. So this is going to be the answer that's correct. Now that's the hard way, if you want to look at it that way. That's the hard way. That's crunching those numbers out by hand. You can also do it in your calculator, since you have your calculator to use. First, you're going to hit the button that says Stat. And we've done this already a couple times. Hit your Stat button, and then hit Edit. Okay. All right. And then you're going to put your X's in L1 and your Y's in List 2. Okay. Put your X values in L1, these right here, and your Y values in List 2. And fill those lists up with that data. Then, after you do that, you hit Stat again. Okay. And then you're going to arrow over. It's a menu at the top, which is going to be Calc. So you're going to have to hit the arrow to go there to get to Calc. And then you're going to pick the choice, and I think it's 4, but it says LinReg, or linear regression. That's going to be the choice you pick, and it says AX plus B. And remember what this will look like. It's going to tell you when and you'll have to hit enter once or twice. Okay, when you do that. And then it's going to give you your value for A, which is 225. So let me highlight some things here so we can. A, when you find it, is going to be your 225. That's going to be your slope. Should be actually negative 225. Okay. So it's going to be negative 225. And your B is going to be the y-intercept, which is the 4135. And we were able to calculate that. Now, the other way you can calculate it, we were able to do B is the 4135. Now, we were able to do it because as you were up here going from 1, you know that when you went back to 0, you added 225, and so we could do that. The other way, and I'm going to erase this right now, the other way you could have figured out this, once you know the slope, is you could have picked a point, okay, and used y equals mx plus b. This is going back and doing the numbers by hand because there's lots of ways you can do this again. But if you know that y equals mx plus b, then you can use this point right here, and let me get a different point. I'm going to pick this point right here. And so what I would do then is I'd plug in and I'd say 3910 is equal to negative 225 times 1 plus b. Then when I add this across 225 here, okay, then what I end up with is 4135 equals B, which again is what I arrive at using 4B. So those are the ways to crunch it by hand, or you can do it in the calculator like I've done on this menu here on the left of this problem. So hopefully your examples that I give you, your problems to work on, will have things where you get this data from a table. And it's very likely that you would need this, or having this knowledge of how to use this shortcut in your calculator is going to help you. Now, example 2 is strictly a formula. The volume of a rectangular prism is given by this function, V, volume, is length times width times height. So which statement is true? Okay. Now, there used to be something with formulas and with functions that we kind of called a function machine, and some people like that or not. This is kind of an old concept. But in this function machine, the way you would do it is you had your input values that went in the machine, okay, and your output values are what you got out. Okay, and the function machine is whatever your formula is, like this. And what you put in, what you have to put in, is the variables that you are on the right side of the equal sign, length, width, and height. And when you put those into the machine and it does this calculation, what you come out with here is your volume. Okay, so this is your input. This is what you put into the machine. Okay, and those are your independent variables. And volume is what you get out of the machine, and that's your dependent variable. Now you may or may not like this little analogy of having this function machine. But the idea of the function machine sometimes can help, because what comes out is always this part here, That's always the output. And then your input is the variables on the other side of the equal sign. Input is independent, output is dependent. So let's look at the wording then of these examples. The volume of the prism depends on the product of only the length and the width. Well, that's not right because it's length, width, and height. The volume of the prism depends on the product of only the length and height. Well, again, no, it's three things we have to multiply together. The volume of the prism depends on the product, which is multiplication, of the length, the width, and the height, which obviously that's true. There's the three variables there. So my answer is C. And it's just asking you to tell in words and recognize in words what that formula means. And example 3. This is an inequality. A candy company sells chocolate-covered cherries in a box. The empty box weighs 4.2 ounces. Each piece of candy weighs at least 1.8 ounces. Which inequality best describes the total weight in ounces, W, of a box of chocolate-covered cherries in terms of C, the number of candies in the box? Okay. Well, this word at least can be a little bit of a problem, because what does that mean? You have to ask yourself, can it weigh more than that, or can it weigh less than that? So at least means, very simply, that that's the minimum it can weigh. So it can weigh, so they can weigh more. Okay, so that means my weight is going to be, could be greater than this. So let's write what we have there in words. We have the weight of the total weight of the box of candies, and we have the box plus the candy inside. Now, we're given the minimum weight, and we know that it can weigh more because some of those individual candies might weigh more than 1.8 ounces. So that's going to mean that this weight is going to be greater than or equal to the box plus that weight they gave us of the candy. Now let's put it in symbols. We have W is greater than or equal to. Now they give us the weight of the box, which is 4.2, plus each candy is at least 1.8, so it's 1.8 times however many candies there are in the box. But again, this could be more. So that means our inequality is the greater than or equal to here. Now we're lucky in that they don't give us any less than or equal to's. We didn't have to really choose that in this problem. But what we need to watch is where does the C go? The C go. Okay, if you see, looking at some of the answers, the C is on the 1.8, and in some of the answers, the C is on the 4.2. Well, what do you have more of? I mean, you only have one box. So, and the chocolate-covered cherries there's more than one piece. So that's what you're going to have multiples of the pieces of candy. And so I think you probably wouldn't have any trouble figuring that out. But it wouldn't be a multiple of the box because you have one box with lots of candy inside of it. So the C goes on the candy. Okay, so the C goes on the candy. So that means we can eliminate this and this because they put the C on the 4.2, which is the weight of the box. All right, and then we can see when we set this up, it's the candy plus the box, certainly not the candy minus the box, to see what the whole thing weighs. So A is going to be the correct choice. All right, in 4, we have the example of some functional relationship, and it says which of the graph best represents which of the following relationships between temperature and time. And just for the sake of doing it, anything, this is our x-axis, and this is our y-axis, and this is your dependent variable, and this is your independent variable. Just to remind you of those things. X is always the independent, and y is always the dependent. Alright, so let's just draw some graphs maybe out here of what we think these things might look like. When we put a cake in the oven, well, hopefully you let it come to the right temperature before you ever put it in. But even if you put it in a little quickly, it's going to go up a little and then it's going to level off. And that oven is going to stay the same while the cake is baking. And that does not look like the graph that we're given. Then we have the temperature of water that is heated on a stove and then taken off the stove, removed, and allowed to cool. So the water is going to get hot. Okay, and it's heated, it's usually pretty steady, and then it's going to cool off. Okay? And eventually it'll level out to room temperature. Cool around and level out to room temperature. The third graph, we have the temperature of a container of hot tea after we put ice in it. Well, again, if it's hot, its temperature starts high, and put ice in it, cools it off, so it's going to be going down. Room temperature of a gym after the air conditioner is turned on. Well, gym I would think would start out maybe warm, and you turn on the air and it's going to cool it off. So maybe like this. But the only one that has a hump in it of all these graphs, obviously the one that most closely would resemble the original problem would be B. That's the only one that goes up and then goes down. Okay. Example 5, now this is one I saw a lot of people missing on STAR and on TAKS. Inequalities, remember, the solution is the shaded part. And if there's two inequalities, it's where the shading parts overlapped. And that was the part on STAR that people, I think, missed, is where it overlapped. Now, the solid line, that you have to notice whether that line is solid. If it is solid, the points on the line are also a part of the solution set. So in this case, the points are included in the solution set. If it's dashed, then the points on the line are not included in the solution set. And that could be really a STAR question. I don't think you're going to see that on TAKS, although you could. Yeah, I just did that wrong. Points not. That's what I wanted to put. Not. Okay. Included. Alright, so this is solid. So everything in the gray area plus every point on the line would be part of the solution set. And so in this case, they don't give us individual points, but they could. They could give you a list of points and say which point is part of the solution set. Or they could give you a set of points and say which one is not part of the solution set. And so you have to be careful. And often in those times, they're going to trick you maybe with something that's on a line and have a dotted or dashed line. But in this, it says which inequality best describes the graph shown below. So we have to find, first thing, you have to find the equation of the line. Okay, well that should be pretty easy, really. We should hopefully be pretty good at that by now. B, remember, is the y-intercept, which is where it crosses the y-axis, and that looks like that's at -2. Then we need to figure out the slope, and we see that the slope is negative. because of the way it leans. Okay. And we see, so first of all, that makes us just that little bit of knowledge without really doing much more. We can eliminate A, because in A there's no y-intercept. That says it's plus 0 if there's nothing written there. And we know that the y-intercept is -2. Of course, all the other ones show -2. But if you look at D, that shows a positive slope right here, and we know the slope is negative, so we can eliminate D. So without really having a lot of information, we can eliminate 2 answer choices very quickly. And then we need to look at, well, what is the slope? And so the way you do a slope, if you're given the graph, is we count. We're going to count the slope. And so we're going to go from, start here at our y-intercept, and we're going to go up 1 over 1, there's a point. Up 1 over 1, up 1 over 1. So as we stair step, we're going 1, 1, or 2. You could go up 2 and over 2. It's 2, 2. So the slope is going to be -1 over 1, which is -1. So that means that the equation that shows a y-intercept of -2 and a slope of -1 would be answer choice C. Okay. Now, let's do a couple other things just as a reminder for some notes here. Solid is greater than or equal to or less than or equal to. Dash is going to be greater than or less than. Remember, the solid means the points are included, so there's also the equal to part. Shaded above here, if it's shaded above the line, if the shading is above the line, that's going to be greater than or equal to. If the shading, and it wasn't here, but if the shading was below the line, okay, then our inequality would be less than or equal to. So those are some reminders of what you're looking at when you have these inequalities. Now, example 6. Vicki works as a sales clerk in a clothing store. She earns $10 an hour plus a commission of 6% of her total sales, which equation represents E, her total earnings when she works H hours and sells a total of D dollars in merchandise. Okay, so she makes $10 per hour. Okay, so let's just write this out in words. Okay, her earnings are her hourly pay plus what she makes in commission. Okay, it's her hourly pay plus what she makes in commission. Now, anytime you have a percentage in a calculation like this percentage here, you have to change that to a decimal. Okay. So you have to change that to a decimal. That's very important. So in our formula, remember, if you have 6%, you're going to start with your decimal here, move it over 2 places. So it's going to be 0.06 in our formula. Okay, well, first of all, that means we can eliminate anything that has not a 6 instead of a 0.06. So that one has a 6, and what about this one? What's wrong with that right there? That's wrong because it's not moved over 2 places, it's only moved over 1. They've just made it 0.6. And we need to go from 6% to 0.06. All right, so again, the next question often is, where does the variables go? So, that's what you're going to have to ask on any of these is, where do the variables? Okay, so we want to know, let's look at, she wants E, her earnings, so E is going to be earnings, that's stated in the problem. And she makes $10 an hour, so she has $10 for every hour she works. Okay, so $10 times H is the number of hours she works. So she's working 8 hours. Plus her commission, okay, and her commission is 6% of her total sales. So again, we have to put 0.06 instead of 6, and her total sales is going to be D. Okay, she sells a total of D dollars, so the variable for that will go there, and it's going to be a D. So where do the variables go? That's critical in these things. So she made $10 for every hour she worked, and 6% of her total sales dollars, and then you add those together, you get her total earnings. So the answer that fits this question is A. Now number 7 example, we have a mapping. A mapping is a way to show a functional relationship. And it says which mapping best represents the function 2x squared plus 1 when the replacement set for x is -1, 0, and 3. So you can, on your calculator, you can make a table and do it yourself. And what you do is you have your x's, which are -1, 0, and 3. And then your y, to figure out your y, you're going to have to put those values in your calculator. So you're going to have 2 times -1 squared plus 1, which is 2 plus 1, or 3. So our value here, our y value here, is 3. And if you wanted to write that in functional notation, that's f of -1. And I put -1 in for every. And so another way to write y then is f of x. I put x in whatever value I pick for x, or they pick for me in this case. So f of 0, I'm going to take my next x value, and I say 2 times 0 squared plus 1 is equal to 0 plus 1, or 1. Okay. And then my last value that they chose for me to figure out what would go on that mapping is point where the x value is 3. So the y value would be 2 times 3 squared plus 1, which is 2 times 9 plus 1. 2 times 9 is 18 plus 1 then is 19. So I have to find the mapping that has those points, and the x values are -1, 0, 3. Well, that means this one automatically goes because that has the wrong x values. And then I have to find the one that has the correct matching, and so -1 right here goes to 3, 0 goes to 1, and 3 goes to 19. So the choice is D. You map the point to the right y value. Okay, that's example 7. And the last example for this first objective is Jake looked at this parabola that's shown, and it says, what is an accurate conclusion that Jake could make about this parabola? Well, the vertex, in this case, is a minimum. So let's just list some things we can tell about this vertex. The vertex is a minimum for this parabola because it opens up. Okay. Because it opens up. The solutions, remember, right here, those would be called our roots. Solutions, or X. Get my writing better, maybe. Intercepts. Okay. And so where is the vertex? Right here, then, is our vertex, which is, in this particular case, a minimum. But not all vertexes are minimums. If it opens downward, then the vertex is a maximum. And so that gives you some information about this particular parabola. If we also can tell that there's no A value, because remember, your typical count is over 1 and up 1, so we should have a typical, if it's your standard just shift of the parent function parabola, you'll have a point over 1 and up 1, and over 2 and up 1, 2, 3, 4, which is where it crosses the x-axis, and over 3, 1, 2, 3, and up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, which are right here. And so this graph is your typical shift of a parent function because of those points. And you know that, again, because that's just the way it will, if it's a variation of y equals x squared, it's going to have those points on it. So what conclusion? Well, obviously this doesn't have a maximum, so we can mark off that. The axis of symmetry is, remember, what goes through the vertex. It's a vertical line, so it's obviously not the x-axis. In this case, the axis of symmetry is, in this particular parabola, the y-axis. So that's a misstatement. So it can't be D. The minimum is at 0, -4, which seems to be true. And the vertex is not at -2, 0. What's at 0? It's not a vertex. It's a solution or a root. So, watch what they're asking you, because there was something at -2, 0. It just wasn't a vertex. All right, that's the end of this lesson.